everyone, this is Kalpana here. In this video, we are going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from phi of x square plus y square comma y square plus z square equal to 0 by eliminating this phi. So we are given a relation. We are asked to form a partial differential equation by eliminating this phi. So we can solve this problem using any of these three methods. Okay, first one, if you consider it as u and this as v, you can use u equal to f of v or v equal to f of u, or third one using determinant form, dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Okay, this we'll see in the next video, and now I'll solve this using u equal to f of v, and finally I'll show you the solution for v equal to f of u. Okay, I'll just directly write it and I'll just show it. Okay, I'm not going to explain y equal to f of u. Okay, fine, let's begin. Given phi of x square plus y square comma y square plus z square equal to 0, right? Consider as equation number 1. Now rewrite 1 as x square plus y square equal to f of y square plus z square. Consider as equation number 2. X square plus y square equal to f of y square plus z square, right? Fine. Now partially differentiate it with respect to x and also with respect to y. Partially differentiating 3 with respect to x. Just apply dou by dou x on both sides of, it's 2, right? I'm so sorry, it's 2. Just apply dou by dou x on both sides of 2 in order to avoid mistakes. We usually make mistakes if we don't apply dou by dou x on both sides of the equation, so I'm writing it. Okay, if you are really familiar with partial differential equation, if you are really good at partial differential equations, you can just skip it out. This gives us, since we are partially differentiating with respect to x, so we'll treat y as constant. This gives us partial derivative of first term plus partial derivative of second term equal to partial derivative of f of y square plus z square gives f dash of y square plus z square into inner derivative, that is dou by dou x of y square plus z square, right? This gives us partial derivative of x square with respect to x is 2x plus partial derivative of a constant with respect to x is 0 equal to f dash of x, sorry, it's y square, right? Y square plus z square into partial derivative of y square plus partial derivative of z square, right? This gives us 2x equal to f dash of y square plus z square into partial derivative of a constant with respect to x is 0 plus partial derivative of z square with respect to x is 2z into dou z by dou x. Since we have a notation dou z by dou x equal to p, we'll just replace it by notation p, and we'll get 2x equal to f dash of y square plus z square into 2z p. Okay, you can cancel 2z on both sides of the equation or just leave it as it is. Fine. Now consider as equation number 3. So we got equation number 3, which is 2x equal to f dash of y square plus z square into 2zp. I told you you can cancel 2 from both sides of equation 3. Okay, fine. Now what I'll do is I'll again partially differentiate 2 with respect to y. Partially differentiating 2 with respect to y. I'll apply dou by dou y on both sides of 2. This gives us, since we are partially differentiating with respect to y, so we'll treat x as constant. Partial derivative of first term plus partial derivative of second term equal to partial derivative of f of y square plus z square with respect to y is f dash of y square plus z square into inner derivative, that is dou y of y square plus z square. This gives us partial derivative of a constant with respect to y is 0 here itself. Instead of writing this step, by looking at this we can say that 0 plus 2y. Okay. And partial derivative of y square with respect to y is 2y. We can skip these two steps and write directly. Equal to f dash of y square plus z square into partial, here also you can do directly, but I am writing step by step so that it can help some students. 2y equal to f dash of y square plus z square into partial derivative of y square with respect to y is 2y plus partial derivative of z square with respect to y is 2z into dou z by dou y. Since we have a notation dou z by dou y equal to q, we'll just replace it by the notation q. This gives us 2y equal to f dash of y square plus z square into 2y plus 2zq. Now you can take 2 common from these two terms, you'll get 2y equal to f dash of y square plus z square into 2 times y plus zq. Consider as equation number 4. Now we got equation number 4, which is 2y equal to f dash of y square plus z square into 2 times y plus zq. Right? Fine. Now observe equation 3 and 4. We have f dash in both the equations. So let's eliminate it using 3 by 4. Fine. 3 by 4 gives LH of 3 by LHS of 4, RHS of 3. I wrote 2 ZP as 2 times ZP, okay, into RHS of 4. This 2 and f dash gets cancelled, here also 2 gets cancelled. This gives us x by y equal to ZP by y plus ZQ. Now make a cross multiplication to simplify it. X times y plus ZQ equal to y times ZP. This gives us xy plus xzq equal to yzp. Now what I'll do is I'll just take this term to RHS. I'll get xy equal to yzp minus xzq, or I'll write it as, so that I can bring all the terms that involves p and q to LHS and the terms that does not involve p and q to RHS. Okay, fine. Now we got the answer. We can again write this as pyz minus qxz equal to xy, which is the required partial differential equation. Okay, we got this answer using u equal to f of v. Now we'll try for v equal to f of u. Let's see this. I'll show you. I'll solve and I'll show you. And this is the outcome. pyz minus qxz equal to xy. Okay, using v equal to f of u. Fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.